The Stuart Models beam engine rebuild, part 14, fixing the alignment problem. Why is the beam out of alignment with the piston rod? And the builder really went round the houses to try and fix this. All that was really wrong with this engine, the cylinder was not in the right place on the base casting. The column that supports the beam is in the centre of the base casting, so as you can easily work out, there's a bit of a problem. The beam itself cannot possibly line up with the piston rod. So the builder of the engine had a brilliant idea. He moved the position of the main bearings on top of the column over to one side. I knew that this was a bad engine when I first started it, but I went ahead with it, and this is as far as I've got. As you can see, the holes are not in a good place on top of the column. I could do it this way. I could fill in the holes and remount the bearings right on the edge of the column. That wouldn't be good either. Someone's already thought of that, because there are some filled-in holes further out on the top of the column. These holes are filled with filler, and with metal it's not the best way to do things. You can fill metal by using other metal. And here's the principle. I'm using Loctite 603, which is a bearing retainer, which will very tightly retain 4 countersunk bolts in the holes in the top of the column. As I was screwing these countersunk bolts or set screws or whatever you want to call them into the holes, I noticed that a plug of filler was coming out of the bottom. So another mistake had been made. The builder drilled these holes all the way through the column, which wasn't really necessary, but such is life. And here to prove the point is a plug of filler on top of the column. And now I think it's time to remove the column. I'm now sawing off the bolt heads. For this job I'm using my old Draper metal cutting bandsaw. Over now to the lathe. I've fitted the 4-jaw chuck, and now I'm going to tightly clamp the base of the column into the chuck. I need to get this part to revolve concentrically, because at the other end there is a centre. It's the centre that needs to be concentric, not the column. The column is just as it was cast, and it's not very true. But before I fitted the live centre into the centre hole, I made sure that was running true. I could have done this a much easier way. All I had to do was carefully cut off the bolt heads and then use the linisher to clean off the bolt heads. Then I would be able to mount the bearings on top of the column, but there are already several holes in this column in the wrong place. 4 of them are now filled with the metal from the bolts, and the other 4 are just filled with some sort of body filler. So I'm going to do it the hard way. Really, I could just linish the top and paint it, and that would be the end of it. But no, I'm going to do it a different way. I'm going to fit 2 metal plates on top of the column, through which the main bearings will be bolted down to the column, giving it added strength. And at the moment I'm trying to get a perfectly flat surface to mount these metal plates. The real answer to this job is to buy a new column from Stuart Models and remachine it from scratch, and that's what I would personally do. If I make a mistake of this magnitude, I put the part in the bin. But then I wouldn't have a video showing you how to repair the holes that are drilled in the wrong place in the top of a Stuart beam engine column. And I freely admit I've done this many times, not on a beam engine column, but I've made a mistake and I've plugged the hole and re-drilled it. 2 of the holes in the side of the column don't have threads in them. The holes were drilled in the wrong place and have been elongated with a file, and they're a right mess. So what I'm going to do is drill the holes a lot deeper using a 7/32 of an inch diameter twist drill, which is tapping size for 1/4 by 40 threads per inch. Then I'm going to make and fit 2 1/4 by 40 threads per inch plugs, which I will screw into the holes. When you're plugging holes in metal, it's a good idea to try and use the same kind of metal that you're plugging. And why is this the case? Well, think about it. If you're drilling a hole in the junction between the new piece of metal and the old piece of metal, if one of the pieces of metal is steel and the other one is cast iron, the drill is going to wander towards the cast iron, so it will be very difficult to drill it accurately. I've used steel bolts to plug the holes at the top, but they're not going to get in the way of the bearings. Famous last words, I'm pretty sure they're not going to do anyway. Plus, the thing that I didn't mention earlier, the 2 metal plates that sit on top of the column, which I haven't fitted yet, are going to be pre-drilled to take the bearings, so will also act as a drill guide for the drill when I drill the cast iron. In this clip I'm threading the holes in the side of the column 1/4 by 40 threads per inch. I drilled the holes quite deep, so this will be a really solid plug, and it needs to be really because it's holding a fairly vital part of the beam engine, and I don't want it to wobble about at any time. Once I'd finished threading the holes, I turned it upside down to get rid of all the chippings, and now I'm screwing in some brass plugs that I made. All I did was thread a piece of brass bar 1/4 by 40 threads per inch, but before I chopped it off on the bandsaw, I used the bandsaw blade to make a screw slot in the top. Then I chopped off 2 of them, and here I am screwing them in position with some Loctite 603. For this job I'm going to use a transfer punch. This will transfer the positions of the holes from the part to the positions on the column where I need to drill and thread the holes to receive the bolts that hold everything in place. Once I got the positions of the holes using the transfer punch, I verified the positions by looking down the holes from the part that's going to be bolted on there. A better idea is to drill and thread just one hole and bolt up the part, then once again use the transfer punch through the hole in the original component to make a mark on the brass plug, and that way everything will line up. I didn't actually do it that way. I did both the holes at one go and everything seems to be okay. But I like to live life dangerously, life on the edge, because it's the only excitement to get these days. Here's a shot of the base casting, and I've scribed 2 lines, one at each side, where I need the cylinder to fit. In order for this to happen, I have to change the positions of the holes. There are a couple of ways of doing it. There's the hard way with a needle file and then drill it out a larger size. Or I can clamp the base casting in my machine vise on the drilling machine, using some pieces of mahogany planking to prevent the vise jaws from marking the paint on the base casting. Then fit a 3/16 of an inch diameter end mill into the chuck and elongate the holes. Then, to make it look less like a bodge, go through each of the holes using a 1/4 inch diameter twist drill. As shown in a previous episode, I'm still going to use the countersunk bolts. These will centralise in the 1/4 inch diameter holes. A quick and simple fix that will hold the cylinder permanently in position to the cast base. But is it going to work? I mount the other side of the entablature, and then using a steel ruler I check the measurement at each side to make sure that it's the same. And yes, both sides measure exactly 13/16 of an inch. And when I lightly clamp the beam to the block on the end of the piston rod, everything seems to be in perfect alignment. And that's it for this episode. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.